Hey, this is Mr. Ward, and I'm going to do a short video on section 3.2, CPCTC, or Kappa, which stands for corresponding parts of congruent triangles are congruent. That may seem like a Captain Obvious statement, that if two triangles are congruent, then every single part of them that corresponds to each other is congruent. There's going to be a couple things that are going to be laid out in this section. There's this Kappa, corresponding parts of congruent triangles are congruent. And then they snuck in a little thing about circles, which says that if you have a circle, every single radius in that circle is congruent. Theorem 18, and that'll play a role in this section. So, got a couple of triangles, and let's say we've proven these triangles are congruent by side, side, side. So ABC is congruent to DEF. Then if we know that they're congruent by side, 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 we can also conclude that E and B, angles E and B are congruent, F and C are congruent, D and A are congruent by the idea that corresponding parts of congruent triangles are congruent, often shortened to Kappa. So Kappa, corresponding parts, CPCTC, corresponding parts of congruent triangles are congruent. Okay, so they lay out a couple of sample problems for you here. And so we got this circle, given circle P, and that tells us that this point here is the center of the circle. Conclusion is AB is congruent to CD. Well, what we can prove, we can definitely prove that these angles are congruent. And since this is a circle at center P, then, and all the radii are congruent, then CP, PD, so PC, PBD, PA, and PB are all congruent, which means we can prove side, angle, side, and therefore these two triangles are congruent. And since the triangles are congruent, then every part of them that corresponds is congruent, and CD corresponds to BA, or AB corresponds to CD. Okay, this one's a little trickier. We got circle O. Center is O, which means that TO and SO are congruent. So what we're given is that it's circle O. We're given that angle T is complementary to angle MOT. Okay, and we're given that angle S is complementary to angle POS. Now, we also know that angle POS and angle TOM are congruent. So those two angles are congruent, and therefore these two angles, which are complementary, let's see, angle T is complementary to MOT. So we know that MOT and POS are congruent because they're vertical. And then because T and S are complementary to congruent angles, then T and S are congruent. All right. And so this angle and this angle are congruent, these middle angles are congruent, and we know that TO and SO are congruent because they're radii. We want to prove that MO and PO are congruent. Well, we use angle, side, angle, side, angle, because of that information I just shared. These two triangles here, this triangle and this triangle, are congruent, and therefore by corresponding parts, PO and MO are corresponding parts of these two triangles. They are congruent. I'm going to do maybe one or two quick examples from the even problem. So number 2, we've got given HGJ and KJG are congruent. So we know HGJ, we know this angle and this angle are congruent. We know that KGJ and HJG are congruent, so we know these two angles are congruent. We want to prove that HG is congruent to KJ. Well, so we know these angles are congruent, these angles are congruent. We also know by reflexive property that GJ is congruent to itself. So we can prove angle, side, angle, side, angle. Those are congruent, so these two triangles are congruent. Because we can prove these two triangles congruent, then we can prove that the corresponding parts of these triangles are congruent. HG and JK are congruent are corresponding parts, and because they're corresponding parts of congruent triangles, they are themselves congruent. I'm going to stop here because I'm running out of time for my next class. I will try and make some more of these videos. I hope this was helpful for you. Please do let me know if it was, because if it was, or if there's something you'd like me to talk about more, I can improve on these videos. So thank you very much.